Title of this video is Motivation for Engineering Research Methods. Socrates once said, "The unexamined life is not worth living." And he meant what he said, but you can't examine your life unless you can ask questions, in particular asking the right questions. And you cannot learn to ask the right questions by answering questions right. As an engineer, you've been taught to answer questions right. You've been given questions by people who know the answers to those questions. And you've learned many techniques to answer those questions. But when you get out into the workforce, that is not enough. If all you can do is answer questions, then you can't ask the right questions. You need to work with people who are not engineers, suppliers, distributors, executives, lots of different people, and you have to be able to deal with all of these questions. And simply being able to answer questions isn't going to help you all the time. If you want to be an engineer at the bottom of the ladder for your whole career, crunch numbers, be a bit basher, you can do that. But how are you going to actually be a leader if you can't ask the right questions? Questions asked by executives, questions asked by different people that you're going to be engaging with over your whole career. The better you are able to identify those questions, the better you'll be as an engineer, but the better you'll also be as an employee. With such a focus on problem solving throughout your studies, you get the mistaken impression that numbers are king, that calculations are all that matters, that written words aren't that important. The reality is that written words are actually more important. You don't want to end up in the situation where your boss asks you to write a report like the first line, and when you hand it in they say, "Start again." The reason we've got this course is for many decades employers have been saying that graduates can't write. Sure, they can solve technical problems, sure they can design things, but you need more. If you're going to be successful as an engineer and moving up the ladder, then you need to be able to do more. Great technical competency, you can be an engineer your whole life at the bottom of the ladder, but you'll never be able to move up. So what do students do with their writing? Well, they try to be a lot more complicated. They want to sound professional, but they don't realize that simplicity is key, and they don't understand the questions that they need to answer. So there are several misconceptions that students have about writing that we need to address. First of all, fancy doesn't make it better. Just because it's longer, just because the words are longer, people aren't going to be impressed by the length of your words. You're not paid by the length of your words. When you get out there, you're going to be nervous when you start, and you're going to want to sound like you know what you're talking about to make it sound professional, but making it longer doesn't equal making it sound professional. So here's some example sentences. These ones are taken from the civil engineering domain, looking at what is different between the way practitioners write and the way that students write. What's the difference? Well, practitioners use much more accurate words. They'll say the preferred option as opposed to the best option. They'll talk about quantities. They won't be vague and airy-fairy. They'll try to be really accurate. So you'll see a great deal of precision, a great deal of simplicity in the way that they write. You don't need to impress people. Accuracy is what matters. Look at the student writing on the right, how long that is compared to the practitioner writing. Each paragraph has one idea and one idea only. Keep it simple, stupid. You've been told that over and over again with respect to design. It's the same with writing. Keep it simple, keep it structured. The accuracy is what matters. People need to be able to understand you. If the writing is ambiguous, then you're not hitting the mark. You've failed as a writer. There needs to be one meaning for what you've written. The title of this video is Writing Incentives. Now, why should I talk about incentives? That might seem an odd thing to mention. Why would you want to write? What would motivate you to write? Well, there's a few reasons why you'd want to do it. If you become a really good writer, you can become an engineering professor. And as you can see on the table of the left, which I took from a recent survey taken on the search engine back in 2020, professors at all of these universities are doing reasonably well indeed. If you can get to the top as an engineering professor, you've got a reasonably good salary. You're on a good wicket. In order to be able to get to the top, you need to be able to write grants. That is, you need to be able to bring money into the university to do research and publish that research in engineering publications. So not only do you need to be able to write well to acquire a grant, you also need to be able to write the publications themselves. More publications, the better publications, the more grants. The more grants, more publications, leads to promotion. It's that simple. When you're in industry, grants is not what you're applying for, generally speaking. You're applying for government tenders. The Victorian government has a tenders website where you put in a submission to work on specific projects which are listed on that website. If you can't write, you can't win tenders, and it's a competitive process. Patents are a way of protecting your ideas, but you can only protect your ideas if you can write them down. A patent only lasts for 20 years, so you should keep in your mind that patents will die. Plenty of patents out there already dead. You look at this particular patent for the mechanical pencil, it's been expired for many years. One source for engineering ideas is to look at past patents. There are plenty of them online. You can look at them, use whatever's in them. Once a patent is dead, it's free for all. So you want to be a leader in an engineering firm. Well, there are a number of things that you need to do. You need to be able to develop plans, which means you need to be able to write. You need to be able to hire people, which means you need to be able to design a position description, which means you need to be able to write. You need to be able to put together strategies, plans, tenders, all kinds of contracts. There is a lot of writing involved in engineering, and that's just not with respect to design documentation, quality, safety. There's a huge amount of writing involved. There's much more than you're led to believe at university. Engineers change the world. They do. The world that we live in is the way that it is because of engineering. And there are many different flavours of engineering. Writing is hard, and you need to keep in mind that what you do actually changes the world. You can make the world a better place by writing, because once you've written it down, other people can use it. So the ripple effect can be felt as long as humanity lives on this planet. When you see somebody in there dressed professionally, they sound professional, and they act in a professional manner, you instantly get a sense of that person. You get a sense of the pride that they take in their appearance, the pride that they take in their work, and the pride that they take in being an engineer. People make those snap decisions within a few seconds of meeting you, and the same is absolutely true of your writing. How much does the title of an academic paper matter? I'm talking about a paper that's actually been published in an engineering journal, not the title of an assignment that's written at university. But let's talk about assignments. If you do a thesis, an honours thesis or a master's thesis or a PhD thesis at university, you only scrape a pass, and most people won't let you do that. Okay, a bad title gives a bad first impression straight away. It can't be too long. It can't be too uninteresting. Okay, you want that first impression to give people a reason to keep reading. You don't read everything as engineers. You're very selective about your reading because there's too much to read. So you've got to make choices, and some of those choices mean you look at the title and you move on. And that's unfortunate because the content may sometimes be very useful, but first impressions do matter. So what is it about titles that is important? Well, there's a list of a couple of things there. If you have titles that are informative, they tell you what's in the document, they're interesting, they're serious, they're descriptive, people are going to want to take a second look. Engineering is a serious business. If the title is fluffy, irrelevant, doesn't actually give you a reason to read the paper, you're very unlikely to duck into it. And part of the reason you're unlikely to duck into it is because there's an absolute mountain of paper. If you look at that list on the right with the top 10 papers, you'll see that the titles satisfy those requirements for highly cited papers. But you've got to be selective about what you read because there's too much reading to do. So who is the greatest of all time? Let's have a look. We've got 3 authors here, eminent authors. Albert Einstein, famous physicist, you've all heard of him. Some of you may not have heard of Oliver Lowry, famous biologist, and fewer of you still will probably have heard of Rebecca Volk. Well, look at the titles. All of them are reasonably long. Some of them are quite descriptive. The titles that you're looking at, they all satisfy those requirements that we looked at previously. Look at that list. We've wiped out most of the requirements, but look at the question. Albert Einstein asked a question in his title, but it's a funny story. Einstein didn't actually write that paper, the fact that it's the most famous paper that is ever cited of his. It was written by his postgraduate student Podolsky, and to be honest, Einstein wasn't that happy with the paper. Podolsky didn't show Einstein the paper before he submitted it. He just wrote it up, stuck the mathematics in it and submitted it, and Einstein wasn't actually that happy with it, and he moved away from quite a bit of the theory in there as things went on. Nevertheless, it's the most famous paper that Einstein ever wrote. So, how many citations do you think these particular papers have had? Well, let's take a look. Einstein got almost 20,000 citations for his paper. Rebecca came in with over 1,000, but her paper is a lot more recent than Einstein's. But the overall winner is Oliver Lowry, biologist, with almost 350,000 citations. So the greatest of all time has to be Oliver Lowry. He created a fundamental method that's used by biologists all the time. And the more useful the thing is that you create, the more you get cited, the more famous you get in your field. That's how it works. Very simple. So how many papers did they refer to within their papers? Well, Einstein is the exception. You don't find any papers these days that doesn't refer to other papers in them. He referred to several equations within the paper. Oliver referred to 25. That's closer to the typical kind of referencing that you'll see in engineering. But Rebecca, on the other hand, referred to 250 papers. So why did she refer to so many papers? That seems like quite a lot. Well, her paper was a review article. And review articles are fantastic for people who are starting out in engineering. You need to do a certain amount of professional development. And if you intend to be a chartered engineer, Engineers Australia expect that you will do a certain amount of reading. Read the review papers. They show you categories within the information. They show you trends. They show you where things have gone and how things have gone. They're the best papers when you're starting out. So she cited 250 papers. We're not going to be asking you to cite that many in this course. So, have you been paying attention? Albert Einstein got almost 20,000. Oliver got 300,000, and Rebecca got almost 1,000. So the number of engineers in the top 100, the number of papers per subject, if you have a look at that graph, you see engineering anywhere? No. Biology, lab technique, and medical methods generally outweigh everything else. You'll see a number of things in there. Mathematics and statistics is up there, but there aren't that many engineers in the top 100. It's partly because the disciplines are more practical. They're solving problems, they're not writing about their solutions so much, but engineers really need to make more of an impact in the top 100. So how much do titles matter? Back to your question. If you submit a bad title for this course, anybody reading your paper will be predisposed to think that it matches the column on the left, that it doesn't really pay much attention to the literature, that it doesn't solve an interesting problem. You predispose the reader by creating a bad title. So be very careful about the way that you start. It is important.